atomic structure assignment with Lakshman Reddy sir 2023-24 season. One very important assignment it is, because if you are looking at these assignments, you will be very strong at the fundamentals. Questions will be repeated, concepts will be repeated, so that it will be easy for you to remember for a long time. Right? I'll be taking few names of my students. Yes, they are attending the class right now. Hope you enjoy this session. If the electron of a hydrogen atom is present in the first orbit, the total energy of the electron is minus, okay, now total energy of the system is minus Ze square by 2r. He's saying hydrogen atom means Z, there is no need of Z, minus E square by 2r. Minus E square by 2r is the total energy of the electrons. What about potential energy? Potential energy is minus Ze square by r. Kinetic energy? Kinetic energy is half Ze square by r, which is positive. Kinetic energy is half Z square by r. Potential energy is minus Z square by r. Total energy is minus Z square by 2r, or you say minus half Z square by r. Fine, Z is equals to 1 because it is hydrogen atom. Good job. Coming to the next. Okay, who is ready? Samir. Yeah, it's your turn. The angular momentum of an electron present in the excited state of hydrogen atom is 1.5 h by pi. The electron is present in, right, MVR is equals to NH by 2 pi, which is equals to 1.5 h by 2 pi, h by pi, sorry, means this n value must be exactly 3. 3 by 2 is 1.5. Good, Samir. According to Bohr's theory, the angular momentum of electron in fifth orbit is, this was previous IIT question also. According to Bohr's theory, the angular momentum of electron in fifth orbit is MVR is equal to NH by 2 pi, 5h by 2 pi. Correct. 5h by 2 pi is, this is pi beta. All these are pi's. Typo error. Sorry for this. 5 by 2 is nothing but 2.5. Correct. Now this question goes to Nikhil. Mr. Palm Nikhil, tell me about this. The angular momentum of a revolving electron in an orbit is equals to, yes, MVR is equal to NH by 2 pi. Do you know how it comes? Angular momentum of electron, we say MVR, how it is? It is moment of inertia mr square and angular velocity v by r, which is equals to mvr. MVR is a product of moment of inertia and angular velocity. mr square into v by r is MVR. Fine. 75th question. Energy of an electron in nth Bohr orbit is given as, energy of electron is given by minus 2 pi square z square me4 by n square h square. Minus 2 pi square z square me4 by n square h square. From where you are getting this? From the total energy equation, minus 1 by 2 Ze square by r. Na? In place of r, you need to put the r value. R value is n square h square by 4 pi square m Ze square. When you apply this one, you will be getting this expression. Correct. Good job. Satyaprakash, come. This is your turn now. The energy of the electron when it is at infinite distance from the nucleus is, quick. The energy of the electron when it is at infinite distance from the nucleus is, right, beta, you are 100% right, it is 0. When it is under the influence of atom, it is negative, and when it is free, infinite distance means it is free, and it will be 0. Correct answer. According to Bohr's theory, whenever the electron jumps from a higher energy level to a lower energy level, the frequency of radiation emitted is related to delta E is equals to E2 minus E1, which is equals to h nu, or nu is equals to delta E by h. Very simple, very simple. 78th question. In an atom, when an electron jumps from K shell to M shell, Suhas, In an atom, when an electron jumps from K shell to M shell, K is KLM, K is first shell, this is third shell. 1 to 3 means energy will be absorbed. By taking energy, it will be going there. Right, Suhas? 79th question. The expression for radius of a Bohr orbit in a hydrogen atom is. Okay. The expression for radius of a Bohr orbit in hydrogen atom is. Quick. Who is ready? Radius. Just now we were discussing. Yeah, this one. N square h square by 4 pi square mz e square. Hydrogen atom, so z is not used here. N square h square by 4 pi square mz e square, z is equals to 1 here. As the electron moves away from the nucleus, its potential energy and kinetic energy, what happens? As we are moving away from the nucleus, the energy of the electron increases. Energy of the electron is directly proportional to potential energy, so potential energy increases and kinetic energy decreases. As we are moving away from the nucleus, energy of electron increases, means potential energy will be increasing and kinetic energy will be decreasing. That's it. Thank you. It is Lakshma Reddy sir.